Hello, this is Tyler Beamer, math instructor, Haywood Community College. This is an instructional video to show students how to find confidence intervals with proportions in the Excel template that I created. This video is going to be based off of this particular homework problem in your Chapter 7, Section 2 homework. This is number 10. And it says a genetic experiment with peas resulted in one sample of offspring that consisted of 443 green peas and 159 yellow peas. Construct a 90% confidence interval to estimate the percentage of yellow peas. So if you open the template that's on Moodle, it says confidence intervals using proportions on Excel. I have highlighted the three cells that you need to put information in from the problem. The first cell is the confidence level. That information should be given to you in the problem, and it is here. Construct a 90% confidence interval. So we want to put that in this cell. We want to put the percentage in as a decimal, so 0.90. And so what you have here is the level of alpha. So that's 1 minus the confidence interval as a decimal. And then alpha divided by 2 is what you get in this cell, E3, and that represents the area in the left and the right tail that is outside of the confidence interval. And then that is used to find the critical value, and the critical value is the z-score on the standard normal table that you would use for that area to the right of that value. Okay. So in this case, that would be the 95th percentile. Okay. Then you want to enter the value for both p hat and n. It might actually be good to just put the value of n in first. And so the value of n is the sample size. So let's look at our problem here. So one sample of offspring that consisted of 443 green peas and 159 yellow peas. So actually in this problem we want to add those two numbers together to get a total of all the peas in the sample, which is 602. Sometimes you have to add and sometimes you don't. It just really depends on the problem. So n represents all of the peas in the sample for this particular problem. And then p hat represents the sample proportion. So in this case, since we're doing a confidence interval to estimate the percentage of yellow peas, we want to find p hat in regards to yellow peas, so the percentage of the sample that was yellow peas. So that's 159 divided by the total value for n, which is 602 in this case. And you could type that in as the decimal. I would probably recommend just doing equals and just typing in the actual ratio. So 159 over 602. And then that way you don't have any rounding error involved. And notice that this is put in as a decimal as well. So this represents basically 26% of the sample was yellow peas, and so we put that in as 0.26. Q hat is the percentage of the sample that is not yellow peas, so in this case would be green peas. And so that's roughly 74%. Once again, we put that in as a decimal. And then everything else is automatically calculated for you based off of the values that you put in, which are, once again, should only be the cells in yellow. If you put in anything else in these other cells, it'll change the formulas. So it'll calculate margin of error, and so margin of error is the maximum likely difference between the observed proportion p hat and the true value of the population proportion p, which you're trying to estimate. And so here's the formula. The margin of error is the critical value, so F3 times the square root of p hat times q hat, which is in this case b6 and c6, divided by n, which is d6, and then we square root that. And then we take the margin of error and we add it and subtract it from p hat, which is the sample proportion. So b6 plus b9, that's p hat plus the margin of error, so that gives you the upper bound of the confidence interval. And then if we subtract the margin of error from p hat, that gives us the lower bound of the confidence interval. So basically what we're saying is the true proportion of yellow peas in the population is between 0.2345 and 0.2936, so somewhere between roughly 23 and 29%. Okay, so let's just make sure that we, so I'm going to write these values down real quick. And you want to be careful to round appropriately, so round to 3 decimal places. It also says express the percentages in decimal form, so you want to keep that in mind. Okay, so we got that part. So, and then B, ask you to infer your answer back to the problem. So given that the percentage of offspring yellow peas is not 25%, does the result contradict the expectations? So we've got no, the confidence interval includes 0.25, so the true percentage could easily be equal to 25%. And yes, the confidence interval does not include 0.25, so the true percentage could not equal 25%. And so if you look at our confidence interval, the true population proportion, which is stated to be 25%, is in our interval, right? 25% would be between 0.235 and 0.294. So that would be our answer here. So there is no contradiction. Okay, so hopefully this video will help you to use that template to do your homework and quiz for this section. I encourage you to use that template as much as you possibly can. And if you have any questions whatsoever, please email those to me and I will respond promptly. Thank you and have a great day.